I have a bit of a cold, so I'm hoping my voice keeps up, but okay. Well, I'm Mark. Red Hat is my employer. I work in the Perf Tools group, it's called, I hope, still. We sometimes change names. And I mostly work on Valgrind, Alpha System Tab, well, and debug stuff. So when I wrote the title, Going from Binary to Source, that's just part of what DWARF is, because if that was all there is, then you just need the debug line mapping. You take an address, oh, that's the source line, but DWARF does, well, so much more. You want to know which functions there are, what parameters there are in the function, are there variables, what is the scope of the variables, what are the types of the various things. So you have that, and then given those variables, you want their values, the location descriptors, which I thought worked pretty well, but then well, you saw the last talk. You want to know ranges of things, so you have debug ranges. You want to know how you got in a function, so DWARF provides you unwind information, not just to know where you came from, but also to get back at the calling the values of the registers when a function was called. You can inspect the values at the previous frame. It even provides, although most compilers don't emit it directly, macros, so that if you have the source and you want to copy paste it, you can use the macros to expand all the defines in your code. Okay, that's a lot of things, and DWARF has a lot of design goals, probably a bit too many. Because they conflict with each other, of course. It's kind of interesting that the last talk was a lot about, well, that's defined by the ABI, because one of the design goals is that it's implementation independent. So in principle, for example, unwinding, you can do almost without any ABI knowledge. The only thing you need to know is which register number corresponds to which actual register on that architecture. So it's kind of interesting to see that it's not always done. What is really nice, at least I think so, now I talked to Tom, and Tom said, that's the worst part. No, that's not really true, but at various places DWARF defines vendor extensions, so it reserves a space of constants. If you use that, then go ahead and add some extra operators or forms, and I actually think that works out quite nicely, because there are a lot of GNU vendor extensions that then get standardized later on. Of course, the problem with the vendor extensions is you have to implement them in all the producers and all the consumers for them to actually work. And I think Tom's issue is that then when they get standardized, you get to implement them all again. But I think it works quite well. This is the one of the design goals that I picked out because I had to pick something to talk about, and when I started to list everything that DWARF5 got from the various GNU extensions, it was way too many. So I like this design goal that tools that have to process dwarf don't have to know about dwarf. And I think that has really helped dwarf become quickly usable, because it means you can easily compose pieces of code with dwarf and combine them. Of course, this bites some of the other design goals, but I thought there were some clever extensions integrated into DWARF5 that counter some of these limitations. Yeah, go look there for the whole standard, and then we just discuss a couple of new data representations. Where am I? Here. So, to compose dwarf from two objects which contain dwarf, you don't need that much. So this you have an assembler where you can reference labels in a data section. You want a way to reference between sections. So, for example, you have the info tree, which describes a variable, and it has to reference where the location descriptor is in the other data section, and you have to have addresses of symbols which you don't know yet where they will be. So you need some way for tools to do the relocation. And it would be nice if the assembler knows how to create lab 128. I don't know how you pronounce it, but a compact form of writing out constants, because otherwise you have to do that by hand. It's a pain. But that's it. With just that, which is basically a generic assembler linker, you can combine dwarf. One of the nice things about that is that you can combine different dwarf producers. You have a C file and an assembler file. You get two object files, and they get combined even though they produce. They have different dwarf producers. You don't have to know anything about the dwarf. They get combined. So, to-doom. Does this show? Of course not. Can I? No. Is it too? Well, it's somewhat readable. I wanted to have an example where it wasn't completely trivial, but even this actually produces too much dwarf. And sadly, it also doesn't show size reduction, because on the other hand it's way too small, so all the overhead just dwarfs it. So all the files are almost the same size, even though I want to show reduction in size. Anyway, what we have is a header file with a simple struct and defines a function that takes a pointer to such a struct, and we have two files. Yeah, this will most likely crash and burn. So this defines the FOP function, and you have a main that calls the FOP function. And the nice thing is that you just create two O files and you combine them together. And the linker doesn't need to know about the different dwarf, what the dwarf data precisely represents. So we just look at the debug info for this. So you have the first compile unit, which comes from f.c. The FOP function address name was resolved, and the statement list is the line table to use for this, and that's at offset 0. That's in principle all the relocation you need. In this case, the matching debug line was placed at the start because it's the first object file, but you will see for the for the second one that the statement list is at the next offset, and all the linker has to do is place the debug line pieces after each other. So in the thing you see immediately here is in this in both the first and the second compile unit, we just redefine that structure type, which is a bit wasteful, especially given that one of the design goals of DWARF was that it shouldn't repeat itself too much. But of course this comes from we want as simple as possible tools to combine DWARF and object files. Yeah, let's go back. Precisely, that's the conclusion. Yes?
So it's a simple concatenation, if I understood well. What happens if you compile with the option so that the linker eliminates the unused functions and so on? Then what is being concatenated there?
And that's a nice question, because the dwarf isn't touched. So if the dwarf in the original object files describes the function that you then eliminate later, it's still described in the...
It is still described, but then you can go look at the supposed address of the object that is defined and see that at the address you don't have much. I mean, there are ways to get back on your feet, but yeah, you don't get it dependency. This is like,
yeah, so and indeed one of the questions is if this design goal is but well so what if we put all those types in their own section, and what if we had tools that had a link once section or a section group, which is a good question to ask because that's that sections and linkers support that. So that's a nice thing. Then if we would calculate some hash or checksum over the type that we put in a special section, then we could reference those sections with the hash as the name. Well, that's basically what debug types do. It was actually an extension for DWARF3 integrated in DWARF4. And the only thing you then need is a way to reference a type with a signature or hash. Or the problem is that it does need a new dwarf unit header, so you couldn't easily combine them, and for that reason and others, they were put in a different section. So, well, now first example. Oh, yeah. Yes. So lots of dwarf. So GC implements this with debug type sections. We compile it again, and this time we see the same debug info. And let's see if I can find FROP and FROP. See, F is defined as the type 2D. Where? Okay. Where's? Which is no, I have the wrong type. I knew I made my example too big. Sorry. No, I have wrong. No, so okay, the argument F is type 92.
and here, this is here, it's a pointer type.
And it's a pointer type and pointer to, well,
That's xenotype unit.
that one. And the nice thing is then in the other compile unit, we should have the same when we pass it. Yes, when we create the variable, it has the same signature. I'm sure that's the same one. And now we have a debug type section with that same signature, and there is only one of them. There is? Yeah, there is. So that's really nice because we need another linker mechanism, but now we deduplicate some information for free. Although, as my example, I was trying to show that it really saves memory, and actually those object files are slightly bigger because this one structure is too small for the header, so doesn't really help there, but most programs include larger headers, more types, lots of types, so it actually really helps there. The problem with it is that it makes things more complicated. There are now 2 die data sections. It's not enabled by default in GCC, even though I believe Tom tried to make it the default. Sorry, Tom. One of the problems was that everybody was kind of lazy, so most consumers have offsets into the data section, and they just keep an offset, and now they have to keep an offset, and oh, it could be one of those sections. I must say I'm showing the GNU extensions, but in the DWARF5 what they did was extend the compile unit headers, so you can now combine type units and all kinds of different units in the same debug info section. So that's actually simpler, but they also added more complexity. Yeah, so it's still very large, and if you look in the example, you see lots of relocations, references to other data sections, and the linker actually has to deal with all that. So what could we need them really for strings. It's really nice if the tools know how to merge strings, because a lot of the dwarf data is strings, and you really want those to be merged. And of course, for the addresses symbols, you need relocations, and you use relocations for the intersection references. What if we could do something about that? And as always, the answer is you add a layer of indirection, of course. So what we do is we put all the addresses in their own section, and that's basically just an index, and then you can use an index into the address, debug address section. And the same we do with strings. We add a new offsets section, so you have instead of having to point directly to a string and asking the linker fix this up, if you put the string somewhere else, you have a new offset, an indirection, so you can just, I want string 1, and just relocate the addresses of strings in that section. And then finally, instead of, for example, the location descriptions saying, okay, that works out. Instead of saying my location descriptor is at that offset in the debug log section, or the range you want the range, what we do is we add an index at the start of the section, and we at the start of the compile unit we just say I'm using the debug log section, that one, and from there you just again use indexes to where your real ranges or log lists are. One of the nice things is that through all that, if we use all those indirections, we can move most of it out of the objects files. So we don't need the linker to even see most of the dwarf data. It still has to see the addresses, but even the strings can be moved away, and this is kind of interesting because shall I first show how to see? Yeah, so what we do here is this is actually the DWARF4 GNU extension, but kind of the same. Oh, I should have shown that it now creates both an O file and a DWO dwarf object file, and a dwarf object file is well, what you see is in the object file you instead of a real compile unit, you have a skeleton, and well, there are some addresses there, and it still has some section offsets. It has the base address to index into the address list, and it has another signature and a name, and well, that's it. And for the other compile unit, it's the same. Well, different IDs, different DWO files. And this is really nice, except if you want to look at the debug info, because now the linker doesn't have to deal with most of the dwarf data. So for elf utils, read elf, I implemented info plus, which picks the after the skeleton. It should actually show. I thought I had patched it in. It should actually show from which file it got. Now it doesn't. And you see in the DWO file, it uses indirect string references, and let's see what. Okay, well, and it can. This wasn't supposed to happen. So this address comes from matching up with the skeleton, seeing where the debug address is, and then using an index into that, which doesn't work. Why not? Well, and it does it every time. Too bad. Sorry.
At least it's consistent.
at least it's consistent, yeah. So and this is also a small difference with DWARF5 here. It still says it uses a section offset. It doesn't really. It should use a different form in DWARF5, but the idea is it uses the section offset from this DWO file. 10 minutes? Okay. I'll manage that. So the same for the other skeleton, and you look up almost most of the info in the DWO file. There. So this is really nice for your normal edit, compile, debug cycle, because your linker, the compiler has to put the debug info aside for most of it, but the linker doesn't need to see it, doesn't need to copy it. We do have lots of duplications again, even for the strings now, but those were already original in the .o files. So DWARF consumers need to be a bit smarter. They have to do some of the deduplication that the linker would do. It's awful for distribution because some programs are links of thousands of O files, and you really don't want to ship thousands of DWO files. I'm also not sure people have used this in Anger yet, really with thousands of DWO files, because for Elf utils I try to be smart and it's all very lazy, so we just open the DWO files and only read them when we need to, and after a couple of thousand you don't get more file descriptors. That's not nice. I assume GDB does something smarter. No? Oh, okay. So, because that is a kind of a concern if you're not in your edit debug cycle, BinUtils comes with the dwarf package file packager, the dwarf packager. I don't know how it's called. And it kind of does what you expect to do. It reads the dwarf data, it sees all the references to the DWO files and adds them together. It acts as a kind of mini linker because string sections make up so much that you really do want to merge all the strings, but it's nice because you only have to update the offset table, and because you concatenate the data sections, luckily you only have that one relocation against it. What it does is it creates a index section where for every DWO it says for the info part and the error part, and well, all the debug sections where it starts and ends. And in principle that's all you need, because you have all those indexes that you now know start at, well, 0 or that offset in the concatenated dwarf stuff. Of course, the next kind of logical step is where getting to a point where the tools aren't simple anymore. So why not write a tool that understands dwarf and does a lot more? And that's basically what DWZ does. The nice thing about if you know about dwarf and you don't mind one extra extension, which is actually also in DWARF5 now, is that you can deduplicate between debug files. You need new forms again to follow string pointers or references, but now you can say, oh yeah, for all those debug files, just look there. I've made one large string section or info section types. So 5 minutes. So I wanted to go in more detail, but the number of references between the various dwarf data sections is kind of daunting, especially if you then combine it with split dwarf. And I thought it was kind of funny. Both these come from the dwarf spec, that they didn't even try to have split dwarf plus supplemental files, because I don't think anybody does that yet. But it is all specified as you should be able to have split types, a split dwarf, and supplemental files together. Oh, right. Yeah. So I just showed that there are still bugs, but I implemented most of this, at least the GNU extensions, with an eye on how they are also done, well, done slightly differently in DWARF5. So if you are writing a dwarf consumer, maybe you want to try out libdw and write documentation for it. No, yeah. Well, it's a really nice library, and every time I say, could you do you want to use it? People say, okay, where's the documentation? Yeah, well, there's a header file. There's a header file. Yeah. No, but it's a nice library. I'm kind of proud that we keep ABI compatibility even while we support newer versions of dwarf. Of course, the value is kind of, you often need to use new functions to really get at some stuff. For example, with the split dwarf, everything works except that old programs not using the newer functions only see the skeletons. But really, it's nice. Yes? Did I do it right on time? Okay, questions? No?
Yeah.
Yes?
About this tool independence, you mentioned that the linker can submit the debug files produced by the assembler without understanding them. If the assembler by default compresses the file, does the linker have to uncompress them?
Yes, it does need to, and there is actually another extension, but that's an extension to ELF. The ELF file format where the compiler compresses all the dwarf data, and then the linker expands, concatenates, and compresses it again. There are people who say that's useful.
So, if I want just to have compressed final executable, I have to tell only the linker to compress the data and not the tools, the intermediate tools.
Oh yeah, you can also do that. Yes, and you can also use elf-utils compress, which actually does that for you. Look. It's not installed. Ah well. Elf compress. Sorry, I don't even know my own tools. Sorry. Yeah. Well. Stupid small screen. So by default it compresses all the data sections. That's what you want. elf-utils, it's great. Okay, sorry. Yes.
When we produce a release build, we don't mind too much about the compile time and link time, and we mind about if ever we have to debug that GDB or whatever, we read the debugging so fast. But when we are developing, we want of course GDB to read fast, but we also want compile fast and link fast.
Yes.
So what is your recommendation about when to use which option for which kind of usage?
Well, for the compile edit debug cycle, I would recommend split dwarf, but that's no. GDB supports it, and elf-utils now support it, and sadly, tools using the elf-utils libraries need to be updated to support it. But it's really easy, super easy API. But for GDB I would, but I'm not completely sure people have used it in Angular, and there are some questions on, okay, instead of the linker spending a lot of time, you now have GDB opening 1,000 files. But out of time. Okay.